Hi everyone, we are on Unit 4, and this is Topic 2. Topic 1, we talked about how to solve systems of equations by graphing. In Topic 2, we are talking about how to solve systems of equations using a method called substitution. Now, when I think about substitution, I think of the word substitute. And even think about if you have a substitute teacher. A substitute teacher, what they do is they replace your original teacher for the day. And nothing really changes. Class goes on, everything goes on, but a substitute replaces your teacher for that class. And we're going to do the same thing with this math problem. What we're going to do is we're going to take something and replace something else with it. So on the left, you will see the steps for how to solve using substitution. So we are going to go through these steps, and as we read them, we are going to do the steps on the right with the problem. So the first step just says, even to start a problem, one of the two equations must have x or y isolated, which means it's going to look like I have right here. It's going to have y by itself with an equal sign, or x by itself with an equal sign. If you look at our first example, I have in a circle right here what this looks like. One of my equations has x by itself. The other one does not. This equation does not have x by itself, but if one does, we're good. Alright, so step 2 says substitute or replace the expression for the isolated variable into the other equation. So let's think about what that says. First, the important part is this isolated variable x. And it says that x equals y minus 2, which means we can replace, I want you guys to write this, we can replace x with y minus 2. Because if x equals y minus 2, it means I can take y minus 2 and replace x with that. So to show you how that's done, I'm going to take my other equation right here, and I'm going to rewrite it down here. So I want you guys to rewrite it. 3x plus y equals 10. Now remember, we just said that we can replace x with y minus 2. So I'm going to rewrite this problem like this. 3. Instead of x, I like to use parentheses so I remember I'm replacing x. I'm replacing it with y minus 2. And then I'm going to finish writing my equation. So I already have the 3 and the x, which I replace with y minus 2. Now I have to write plus y equals 10. So look at step 3 over here. It says, step 3, your new equation has only one variable. Distribute if necessary and solve the equation. So it says distribute if necessary because sometimes we have to, sometimes we don't. In our problem, we do have to. We have to distribute the 3. When we distribute the 3, we get 3y minus 6 plus y equals 10. I only have one variable here. They're on the same side of the equation. Let's combine like terms. 3y plus y is 4y. Minus 6 equals 10. I know how to solve this. Add 6 to both sides, and I get 4y equals 16. Divide by 4, and I get y equals 4. Alright, so I now know what y is, but remember, a system of equations has two variables. I only know what y is. I only know what one variable is. So we have to look at this last step, step 4. Take your solution from step 3. Here's my solution, y equals 4. And plug it into either equation. And I wrote here, pick an easy one. There's two equations. Pick the easier one and solve for the other variable. So I have y. I need to find x. So to do that, I'm going to pick my easier equation, which is x equals y minus 2. I'm going to write it here, x equals y minus 2. And I'm going to plug y in, or plug 4 in for y. So I get x equals 4 minus 2 and solve this simple equation. 4 minus 2 is 2. So there's my x coordinate and my y coordinate. Remember, the whole point of a system is that the answer to a system gives you an x and a y. It gives you a point. This is my solution. It is the point 2, 4. All right, moving on to the next example. Again, same idea here. So example 2, we just have a different type of equation, and our step 1 for this one says, what if both of the equations have x or y isolated? So that means they'll both be written with y's in front, or they'll both be written with x's in front. Look at what this looks like over here with example 2. See how I circled the important part? Both of my equations are written y equals and y equals. If that happens, our step 2 says set both equations equal to each other. And we can do that because they're both set equal to y. So I'm going to write here set equal to each other. Because if they both equal y, that means they have to equal each other. So our equation would look like this. 4x, that's from my first equation, right? That's this 4x. Equals, my other equation is 2x plus 10. Okay, and now let's go back to our steps. Step 3 says your new equation has only one variable, x and x. It does. The variable is on both sides. Solve the equation. So we just have to remember how to solve this equation. When I have variables on both sides, I can't just combine like terms. How we learned how to do this in Unit 2, or maybe Unit 1, is we picked on the smaller of the two, which is 2, and we subtracted 2x from both sides. And when we do that, we get 4x minus 2x, that's 2x, equals, these cancel out, 10. Simple equation to solve. Divide by 2, and I get that x equals 5. Now remember, this system is not complete. I only have an x here. I also need to know what y is. To find y, the step is the same as last time. Take your solution from step 3, here's my solution, and plug it into either equation. Pick the easy one and solve for the other variable. So I have x is 5. My easier equation is right here, y equals 4x. I plug 5 in for x. Y equals 4 times 5, which means y equals 20. Now I'm going to write my solution. This is how I like to write my solution. Solution is, I'm going to write it as a point because I know this is the point where x is 5 and y is 20. That is the point where if I graphed both of these lines, they would meet. All right, for these two examples, I am just going to go through these a little quicker since we already walked through the examples, and I'm going to determine whether they match example 1 or example 2. Now this one, I'm going to write up here, matches example 1. And the reason is because one equation is set equal to y. So what I do is I take what y equals. Y is x plus 9. Now I'm going to rewrite my first equation. 4x minus 2y equals 12. And where the y is, I'm going to replace it with x plus 9. So it goes like this, 4x minus 2. Instead of y, I'm going to write x plus 9 equals 12. Now I have a new equation to solve. It looks like in this equation, same as last, I have to distribute. When I distribute, I get 4x minus 2x, careful with positives and negatives, minus 18 equals 12. Like terms here, 4x minus 2x is 2x, minus 18 equals 12. Add 18 to both sides. 2x equals 30. Divide by 2, and I get x equals 15. Remember, we aren't done until we solve for the y as well. I'm going to do y in a different color right here. My simple equation is y equals x plus 9. Y equals x is 15. 15 plus 9, which means y equals 24. My solution is 15 is my x, comma, 24 is my y. All right, let's try example 4. Now for example 4, looks different. So I want you to think about which one we are going to reference. I'm going to say that this one matches example 2, and it's because if you look closely, both equations are set equal to y. If they're both set equal to y, we're going to set them equal to each other. So my equation is going to be negative 2x minus, plus 15. Because look, that is what's highlighted in, I'll do red up here. And then the other equation I'll highlight in blue, and I'm going to put that here, equals 3x plus 5. All right, now let's solve this. I have x's on both sides. I'm going to get rid of my minus 2x by adding 2x. Cancel. Add 2x. I get 15 equals 5x plus 5. Subtract 5 from both sides, and I get 10 equals 5x. Divide by 5, and we get that x equals 2. To solve for y, I pick either equation. I think the second equation looks a little bit easier. This is the second equation, 3 times x plus 5. I know what x is, so I write y equals 3 times 2 plus 5. And then I get 3 times 2, that's 6, plus 5, that's 11. My solution is x is 2, y is 11. All right, here's our last couple examples. So, example 5, it looks like this matches the one where only one variable is set equal to x. So x is equal to, there's some students out in the hallway, sorry, excuse me. X is equal to negative 2y plus 4, which means in my other equation, 3x plus 6y equals 12. I'm going to replace x with negative 2y plus 4. So this is going to look like 3, negative 2y plus 4, and then plus 6y equals 12. All right, I'm going to distribute. Negative 6y plus 3 times 4, 12, plus 6y equals 12. Like terms, negative 6y and positive 6y, those cancel each other out. I get 0. What I'm left with is positive 12 on the left equals positive 12. Now this has happened before. 12 equals 12. This is a true equation. So what happened is that the variables canceled, and we're left with something true. We're left with a true equation. Do you guys remember what that means? From Unit 1, that means that there are infinite solutions. So normally our answers have been just one intersection point, an x and a y. This means there are infinite intersection points. Infinite means there are so many it is impossible to count. They keep going and going and going. There are infinite points of intersection. All right, our next example is also starred. So if you look at example 6, this is also a special case. You might be able to predict what's going to happen in this case. If we set this one up based on our other examples, you'll see that they're both set equal to y. So we are going to set them equal to each other. I'm going to set this up. Let's see. I'm going to take the top equation and put it in red, the bottom in blue. I'm going to set these equations equal to each other. So just setting this up, I'm going to put 4x plus 5 here. 4x plus 5 here equals 4x plus 1 in blue. All right, when you go to solve this, I have x's on both sides. So subtract 4x, cancels, and also subtract 4x, and this also cancels. We have on the left 5, on the right 1. Now something very different happened here, because 5 does not equal 1. The variables canceled, and we are left with a false equation. Do you remember what that means from Unit 1? That means that there are no solutions. And in this case, since we're dealing with a system, our answer is not an intersection point, because no solutions means that there are no intersection points. So previous answers had an actual location. These ones have no intersection points. If you want to think beyond what we just did, if you were to graph these, what kind of lines have no intersection points? These lines would be parallel. All right, so you guys can work on your homework. I believe we are on homework number 2 in your Unit 4 packet. Good luck.